Okay, I'm going to go over two additional problems for section 5.3 that are going to mirror the two problems, kind of three problems because one is two parts, that you're going to need to submit for a grade. Okay, so in number 37, again, this is on page 243. It says, find the z-score for which 5% of the area's distribution lies between negative z and positive z. Well, if we have 5% in the middle, we're looking for that negative z and that positive z. And whenever we have area under the curve and we want to find the z-scores, using our calculators, z is going to again equal the inverse norm, and then we enter in the cumulative area. That means the area at the bottom of the curve. Well, properties of the normal curve, we know the whole curve is 100%. We could take away the 5% in the middle, and that's 95%. 95% divided by 2 leaves us with 0.475% actually in each of our tails. So if I enter in the inverse norm, okay, again in the calculators, we go into the distributions. I'm going to hit second distribution, or the variables button for distributions. I want option 3, the inverse norm. I enter in the area at the bottom. Now, the calculator, remember z-scores, we went around to 2 decimal places. The calculator only gives us the negative. But we have 2 z-scores, again, that mark that middle 5%. So our answer is both positive and negative 0.06. Okay, at this time, you might want to pause the video and go ahead and complete number 38. If not, you can continue watching. And we are going to cover number 43. Number 43 on page 244 is going to mirror number 44, which you're going to need to submit your answer to. So in number 43, it says the time spent in days waiting for a heart transplant in Ohio and Michigan for patients with type A blood can be approximately normally distributed as shown by the graph. So in the margins of your page, the important piece of information that we need to pull from that image with the normal curve is that mu is 127 days with a standard deviation of 23.5 days. We're going to create our own sketch anyways. It says in part A, what is the shortest time spent waiting for a heart that would still place a patient in the top 30% of waiting times? So we're looking for the top 30%. Okay? Remember, the top of the curve is the right side of the curve. We know that our average is 127. The top 30% is on the right. We're looking for x, the number of days, okay? Which means we need to be able to find our z-score for that x. We have 2 options. So this is the right side of the curve. The inverse norm only sees the left. Well, I know at the left, there's 70%, 1 minus that 0.3. Or because the curve is symmetric, we could still do the inverse norm of 0.3, but based on our picture, we should recognize we need a positive z-score, so we switch the sign. So again, second, variables for distributions, option 3. I'm just going to enter in 0.3 and switch my sign. So it's negative 0.52, which I know I'm going to need a positive 0.52. So then to find the number of days, it's x minus the mean divided by our standard deviation of 23.5, and again our z-score. We calculated at 0.52. So for x, again, we're going to multiply both sides by 23.5. Then we're going to add 127 and we get 139.22. So we could say about 139 days. Okay, in part B, we have the same mean, same standard deviation. It just says, what is the longest time spent waiting for a heart that would still place a patient in the bottom 10%? So the bottom is down here, 10% is in our tail. We're going to go through the same processes, except for this time, z-score is a little bit easier to find because we have the bottom percentage. So we just do the inverse norm of 10%. The z-score that we get is negative 1.28. We plug all this information into our equation. And then we solve for x. Negative 1.28 times 23.5, and then we add 127 to both sides. We get that x equals 96.92. So we could say about 97 days.